Associated circular motion comes in handy when we want to find the time, when we deal with time under simple harmonic motion. For example, suppose that a particle that moves under simple harmonic motion is at this point first, let's call it P, and within a certain time, it has moved to this new point Q. Right. Now we want to know what TPQ is. How long it takes for the particle to go from here to here. Now to solve this problem, we're going to use associated circular motion. Right. So first, let's right. So what we do here is that first we mark the amplitude with respect to the center. First we mark the amplitude with respect to the center. Then we make a circle by keeping this a radius. You have to do this, right? Do this construction. Then the associated position for the particle at P would be this position on the circle P dash. And for this position, there will be a corresponding position on the circle Q dash. So when the particle goes from here to here, it is equivalent to a particle moving on a circle which moves from P dash to Q dash. Right. So this position with respect to this horizontal axis makes an angle theta. Let's take this angle here alpha with respect to OA dash, and the angle corresponding to this position P dash, let's call it theta. Right. So within this time TPQ, the particle has rotated by alpha minus theta. Alpha minus theta. This is the amount it has rotated within that given time. So how long will it take to rotate? You can easily obtain this answer. TPQ would be this angle alpha minus theta divided by the angular velocity, which is omega. So now what is alpha? Alpha is this. Now this is A, the radius A. So alpha is cosine inverse B over A. B divided by A. Cosine inverse B divided by A. That is alpha. Right. Then what is beta? Sorry, theta. Theta is minus cos inverse A divided by capital A. Simple A divided by capital A. So this divided by omega gives you the time for the particle to move from P to Q. Now suppose you want to get the time for the particle to move from P to somewhere on this side of the line. So suppose we have to extend the circle. Suppose this is Q. Suppose this is Q to the point Q. Right. So there will be a corresponding point on the circle path Q dash. Right. So this is A. Let's call this beta. And let's call this Q is C distant away from 0. C distant away from 0. You can see that you can make a right angle triangle here. Then cos beta is C divided by A. Cos beta is C divided by A. Now we know that this side is positive and this side is negative, but for the moment we are gonna disregard the sign of the C here. C should be a negative number, but we don't worry about that. We just want to find the angle. So angle, this angle, it has rotated by. So what is this angle? So this angle would be pi minus beta. Now we want to find the time from P to Q, right? To find time from P to Q, we need to know the angle it has rotated when it moves from P dash to Q dash on a circular path. So pi minus beta is this angle with respect to the horizontal axis minus theta give you the angle, this angle, right, divided by omega, right? So what is the answer now? Pi minus beta is cos inverse C over A, then theta is cos inverse simple A over capital A divided by omega, TPQ. You can see how easy it is to get time involved with simple harmonic motion using associated circular motion. So we're gonna use this very often when we are dealing with problems.